Hi 601 students. In today's Collaborate session, people seem to be a little confused about doing forecasting with seasonality. So I thought I would do a quick video based on problem 523 in your homework, and hopefully this will help you a little bit. And let's begin by graphing the data to see if visually we can confirm that there is some seasonality. What I'll do is I'll highlight the data, insert my scatter diagram with lines, and to me, I do see some seasonality. Take a look. From quarter one, we go down, up, down, up. Same down, same up. Well, not perfect pattern, but anyway, it's sort of there. So that does look like there's some seasonality. I don't see strict horizontal graph. I do see there's a little bit of trend also, and that will be built in the last part of the problem. So whenever we have something with seasonality, the way we're going to arrange the data is not like you see it on the screen in the homework or in the textbook, but rather one variable for year, one variable for quarter, and one for the data. What we're going to have to do in order to do a regression on quarter, the seasonality, is to create new dummy variables. Why is that important? Because quarter, the way it is here, is strictly a nominal level variable. It's a label. And the difference between a 1 and a 2 is not the same as the difference between a 2 and a 3, as would be the case in a variable that's numeric. So what I'll have to do is to create a variable called quarter 1, another one called quarter 2, and then another one called quarter 3. These are three dummy variables. Remember that the number of dummy variables that you create is always is always the number of periods minus 1. Don't mind me, doing fine here. So if we have 4 quarters, it's 4 minus 1, or 3 dummy variables. Now for the first line of data, that is quarter 1, so I'm going to put a 1 underneath the quarter 1 column, zeros elsewhere because it's not quarter 2 or 3. I'll put a 0 in quarter 1 for the next line down, but a 1 in quarter 2 because that's what it is, and a 0 in quarter 3. For quarter 3, I'll have a 0, 0, and a 1. Quarter 4, that's not quarter 1 or 2 or 3, so I should put zeros all the way along. Now that I have that pattern created, I will copy and paste down here and here so that I have the pattern continuing. Now once I do that, I can do my regression. I can do data analysis, call up regression. My Y range is my actual data. My X range, that's my 3 dummy variables. I'll click labels, and the output range will tell me that I will put my data or my analysis starting right here. So do we have a good predictive model? Well, our model has 39.8% predictive power. Not great. Multiple R, is it close to 1? Not too close to 1. Most importantly, though, the significance is not less than 0.05, so it really is not a very good predictive model. If for some reason, though, we really wanted to use that model, we would have to pick up these coefficients here, and we would have to form our equation that says y hat equals 6.67, I'm abbreviating, plus a negative 1 times quarter 1, plus a negative 3 times quarter 2, plus a negative 2 times quarter 3. And by the way, if you wanted to just put negatives instead of plus negative, that's absolutely fine as well. So that's my regression equation. What does all this mean? Well, quarter 4 is the one that has zeros all the way along, zeros for all 3 quarters. So for quarter 4, our prediction is going to be 6.67. For quarter 1, it's going to be 1 less than that, 5.67. Quarter 2 is going to be 3 less than that, 3.67. And quarter 3 is going to be 2 less than our baseline, 4.67. Well, let's do the analysis and prove all of that, and we'll do that for year 4 for all 4 quarters, quarter 1, 2, 3, and 4. I'll go ahead and copy my pattern down. So here's my prediction. Equals 6.66, etc., etc. I'm going to drop the pluses and just say minus 1 times this cell, and I click on the cell so that I can copy the formula later, minus 3 times this cell, minus 2 times this cell. I'm using all of my slope coefficients and just multiplying by the cell. And what I end up with for quarter 1 is the 5.67 that I predicted a moment ago. And here are all the other ones. I could also go ahead and bring that up, so now I have forecasts for all the way along for quarters 1, 2, 3, and 4. And do notice that the same 4 numbers just keep repeating over and over and over again because I have not yet put in a trend factor. I'm assuming it is horizontal, so I will have the same numbers. Now, how do I do my mean squared error? Well, let me remind everyone that the mean squared error says just go ahead and take your error factors, square them, and then average that. So what are my error factors? Well, for the first line, my actual data is 4. I'm going to subtract off my forecast of 5.67. That's my error factor, the 1.67 off. I'll square that. I will then take that and drag it down, but only as far as I have both actual as well as forecast value. I can't drag it down to the next 4. What would my MSE be in that case then? It would just simply be the average of all of these error factors squared. 1.88888, etc., etc. And don't forget to round that off to 3 decimal places for Cengage. All right, well, I think we've got that handled. Real quickly, if we did want to bring trend into the analysis, as you would in the latter part of the problem, all I would have to do is to create a new x variable, and that x variable would be time. And literally it would just be 1, 2, 3, 4, 5, 6, 7, 8, 9, etc., going through a count of all of our different quarters. If indeed we then run our regression analysis where all of this, all 4 variables would be independent variables, you'll get the next analysis, find the MSE, and we'll see which one's the best. That's about it. Scream if you need any help. Bye-bye.